Welcome back, folks. I decided we're going to do one of the dependent supply problems. I don't think it's worth going through all three. So I picked one out, and we're going to look at how we can kind of break up the problem. We can use the shortcut on part of it, and we got to kind of revert to the long method for the other part of it. So we just got to be comfortable with which one to use. Okay, so we've seen this problem before, and we're going to go do the shortcut on it. So we figured out that the nodes were here, here, and here. I don't see any voltage supplies, so we're going to write all KCLs, KCL for A, B, and C. Now I have to stop and say which KCLs, which equations are going to involve a dependent supply, and those are the ones that I'm going to slow myself down, go a little slower, all so that I get the right answer. So A is the only one that has the dependent supply connected to it. So that's the one that I have to kind of slow down. B and C, I can go straight to the shortcut. Okay, so let's write the KCL for A to start with, since that's the one that we got to go a little slower. And this should look like what we did in the last video, but, you know, doesn't hurt. 3VO is going in. Oh, I got to think about current directions now. Okay, we're going with blue. Let's go with blue. Minus VA over 10, minus VA minus VB over 4, and minus 2 is equal to 0. So we got to look for VO. Hey, there it is. And figure out an expression for that voltage. VC is connected to the positive side, VB is connected to the negative side, so we can go ahead and plug that in. So 3VC minus 3VB, as I distribute that gain to both of these terms, minus 1/10 VA minus 1/4 VA plus 1/4 VB, and I'm just going to move that 2 over to the other side by adding it. Alright, I'm moving a little quicker. We've seen this problem before. We've written this identical equation before, so you know, if I went too quick on that, go back and look at the other video where I solved this problem. Okay, combining stuff up here, we got negative 1/4 VA. Where's VB? We got negative 1/3, and we add a quarter to that, so it's going to be negative 2.75 VB. Oh yeah, that feels familiar. And then VC. Oh, I missed a VA. I hope you were yelling at your monitor. Go slow, folks. Name of the game, go a little slow. There's VA. I got 2 of them there. Okay. How did I end up with 2 of them there? Yep, I got that one, and I got that one. So let's see, negative 0.25 and negative 0.1 is going to be negative 0.35. To combine those two. Did I screw it up for B? I don't think so. There's B. And then C is over here. Okay, so now I'm really going slow because I don't want to screw it up. I don't mind doing something. I just mind doing something twice if I messed it up, right? So we try to get it right the first time. So we got plus 3 VC, and that's all equal to 2. All right, that one's ready for prime time. Okay, so I can go ahead and build my matrix now, and we'll start it out with that, right? So we get negative 0.35, negative 2.75, 3, and we get a 2 over here. All right. Let's see. We got to do B. So what's connected to B that's also connected to A? Looks like the 4 ohm, so it's negative 4 ohm. What's connected to B? 1/4, 1/5, and 1/2. Okay, what's connected to B that's also connected to C? We get negative 1/2, and no current flowing in or out of that. Okay, last one. So I could do the shortcut on that, no problem. Last last one, we say what's connected to C that's also connected to A. No resistors. I'm going to scroll up just a skosh. Yeah, that's a current supply. What's connected to C that's also connected to B? Looks like that 2 ohm R4. And then what's connected to C? Also only the 2 ohm. Okay, now we have 2 supplies coming in. I think they're both going in if I remember. Yeah, they are. So I got 4 amps going in, and I've got 2 amps going in. Since they're both going in, they're both positive. 2 plus 4. Last time I checked, that's still 6. Okay. VA, VB, VC. All right. Let's solve it. And I'll do it as quick as I can, because I'm trying to show you that this is a fast method to accurately get the solution. Unless you fat finger your calculator like I just did. Let's try that again. 3, 2, negative 0.25. 4 inverted plus 5 inverted plus 2 inverted. Negative 0.5, 0, 0, negative 0.5, 0.5, and 6. And from that, these don't feel familiar either. 176.8 4. That's going to be in volts. These are rather large. 111.58 volts. 123.6 volts. Okay. I'm being brave again. I haven't checked my answer yet. If you think that I get the right answer the first time, every time, thank you, but that's just not true at all. I definitely screw up, and hopefully I catch myself before something goes into production or gets somebody hurt. So let me go find our previous video for this one. Yeah, okay, hold on, I'm going to pause. I found an error in the last video. Once I found the image, the numbers didn't match. These are correct. I just checked myself. And I'm going to have to go fix that last video. Maybe I'll be good and I'll be honest about it. Think I will? I probably will. I make mistakes. And I'd rather you see me make mistakes and then correct them, but I caught myself on this one. And it still worked out. The final answer was correct. That's the kind of cool part. But the node voltages were off a little bit because I made an algebra mistake. Horrible, horrible, horrible. So anyhow, this shortcut was done correctly. I'm happy with it. We got to mix and match. If you have an equation that involves a dependent supply, do it the long way. And if you have equations that don't have dependent supplies in them, go ahead and use a shortcut. You'll be fine. Okay, so you've already seen me correct that video. It's like time travel. Woo! It's good stuff, right? So now you know where I figured it out. We're going to look at some op-amp circuits, shortcut with the op-amp as well. Stay tuned and good luck. I'm glad you stayed tuned. I decided to go back and fix that and all of that, and then I realized this image got corrupted, so I had to recreate it. It's been a mess. I wanted to finish it off correctly because it does match these values. So if we're being good about it, I'm trying to be good, we can see that we end up with an equivalent system of equations. I just want to be 100%, right? Finish it off. 176.84. My rounding's a little different between the two. But we end up with identical answers because we have an equivalent system. That's all. Okay? Op-amps. Shortcut with op-amps. I promised you. They're coming. Stay tuned. Good luck.